Welcome to Funnel Reboot, the podcast that shares ideas on how to upgrade your lead generation. Here is your host, Glenn Schmeltzley.
Hey, Glenn here. Welcome to Funnel Reboot. Today we're diving into forecasting. But first, let me remind you that your feedback is so critical. I would really appreciate hearing a future book that you think we should cover, or a topic, or a certain person to interview. You can do that by reaching out on social at Funnel Reboot or at the funnelreboot.com site. To today's show, I want you to look under your couch. I want you to look somewhere down in your basement, maybe in your attic. See if you own a crystal ball. What's that? You don't have one? So that means you can't predict the future, right? Well, I have good news for you. You actually don't even need one. You see, when you feed a lot of historical information into a machine, it really doesn't have to know what those numbers mean in business terms. Thanks to sophisticated data models, machines can act like a crystal ball just by determining the trends that are behind the numbers, including what turn out to be pretty accurate predictions of what the future numbers will be. That's not all there is to data science, though, and our guests believe it's these kind of things that we can use to analyze our marketing and carry us up this evolutionary ladder of analytics from what happened to how it happened to how it might happen. This episode talks a lot about cloud computing, which crunches these numbers. It's talking about how data science has changed from being used only on high-end servers to something that any one of us can use on a laptop at a fraction of the cost. We'll also cover the skill sets of the people that you probably want to have doing the setup of the machine work. To learn about how you can start implementing data science in your marketing, come and join me for a talk with two people who are really well versed in this. The first is a person who lives in the UK. He showed a penchant for math, which led him to Oxford University, bachelor's degree in mathematics. After spending time living in South America, he moved home and took a liking to the quant-heavy world of pay-per-click marketing. He's taken the last 10 years of experience consulting on digital marketing and web analytics projects to found Forecast Forge, a quick and accurate forecasting tool that uses machine learning. Our second guest was an early SaaS pioneer and helped change the PR industry by creating one of the first companies to develop a real-time monitoring and analysis platform that was able to successfully generate business intelligence from both traditional and social media. He would lead the company as both the CEO and chief architect and developer of the platform, as well as being awarded 2 patents. Leading his company through several significant transitions, including using big data and machine learning, he determined how to take both journalist and publication data to create new markets with the data. His company, Mediamizer, would be acquired in 2014, and he would later go on to improve his analytical capabilities by achieving certifications in data science and AI from the University of Waterloo and the University of Toronto, adding to a degree that he originally had from Western University, as well as PR and Communication Studies from Algonquin College. Let's go talk to Richard Fergie and Brett Serjeantson. So today we've got an interesting format. I've got 2 people on with me, and the first person I'd like to have say hi is Brett Serjeantson. How you doing, Brett?
Doing well. How are you doing, Glenn?
Fine. And the second person I'm excited to have on is Richard Fergie. How's it going, Richard?
Hi, it's going pretty well over here.
Yeah, and where is here?
So I am in the UK. I live in the northeast part of England near Newcastle.
Fantastic. And Brett, where are you joining us from?
Ottawa.
Ottawa, Canada, as am I. So what we're here to talk about today is the use of data science for marketing, trying specifically to boil into some of the things in paid media marketing. We could even boil it further down to paid search marketing with the likes of Google, where we're trying to see what sorts of analysis are possible using data science and even layering on some artificial intelligence and machine learning. And before anyone, clicks away from this, I want to allay your fears. There's not going to be any extensive math here. We're not going to get into code talk. We're just going to skip over the concepts so that you can understand how you can apply it into your marketing. So maybe, Richard, we'll start with you, and maybe if you could take us through just a little bit of how much involvement you've had in the past with pay-per-click marketing and with working with companies to help them understand the search data, how people find their website, what people do on their website, and yeah, just take us through a little bit of where you've been.
Yeah, so you've pretty much described my path with with that little summary, really. I studied maths at university, and then my first job outside of university was in pay-per-click marketing. I never thought I was going to work in marketing, but some stars aligned, and now here I am. Yes, so that was mainly with Google Ads, a little bit of Bing, a little bit of Facebook, that kind of thing. And then as my role developed, I began to be spending more and more time on trying to measure those marketing efforts. Like make sure that if you're spending the money, that you're recording your return in the correct way. Certainly made a few howlers with that, with like sending people, hundreds of low quality leads and telling them that their campaigns were going really well when actually they weren't.
Right.
Which is, yeah, it's
Yes.
like it's very easy to do. I think if you're a paid search person, you get in the mindset of like, I'm going to make this number go up, and I'm going to keep that number below a threshold, and like, as long as those two things are happening,
Yeah.
you're really happy, and you're like, I'm doing a great job, everything's going well. And then, but if those numbers aren't representative of what's important for the business, then you end up in a whole world of other problems.
So this is an important point, because we have one or two constraints that we have to start somewhere, and places like Google Ads starts with saying you're going to spend, or you're going to declare what your budget is, and that amount is presumably going to stay the same every day, right? So when they start with that barrier, your mentality becomes, how do I spend up to that amount? When the real question that you should be answering, just like you said, is the amount that I'm spending maximizing the number of good quality leads that I'm bringing in?
Yeah,
right? And those are diametrically opposed.
They certainly can be. And in this particular case, I was sending a lot of low quality leads that were never going to turn into good customers for them, but they still triggered the conversion tracking. So everything looked like it was going great to me.
And they would have done it whether we are in high season or in low season for what that particular business ought to have.
Yeah, exactly. Yeah. And there's so many levels of that, and I think the answer can be quite different for different businesses. There's not always like, okay, so here's how you set up your tracking to measure what's important for you, because what's important for them changes depending on what their strategic objectives are, and like what they're selling, or what the economics of that particular thing are. So I got quite into almost like setting up measurement correctly. So the website tagging side of things became more and more important, or like integrating data from back end systems alongside the paid search data, which was still my main focus at the time. But as I began to move more into the web analytics side of things, then obviously there's more analysis opportunities become available, and I was finding that a better fit for my skill set, and it was opening up more opportunities into the sort of data science area. Like, it wasn't data science was a very new thing at that time, so I probably wouldn't have said like, oh well, now I'm doing data science, because that wasn't a thing that was well thought of as a category. But it was moving more into like automated analysis, or like the simpler parts of machine learning. to
and if I were
identify opportunities or
sure,
identify abnormal
so if I were
behavior.
hovering over your shoulder, if I were hovering over your shoulder at that time, would I have noticed that the tools changed? That you, for example, weren't in the interface of the ad platform or analytics as much, and maybe you were more in a spreadsheet or even pulling the data into a database?
Um, Possibly it was a gradual change for me. Like some of my work when I was very very paid search focused was already reliant on code and querying databases
Really?
and things like that. Yeah, so stuff like hotel room availability to adjust bids
Right.
in specific location or bids for people looking for specific locations. It'd be worth for things. Hotels are a really interesting example, and I've done other work with them since. For example, okay, so it's Valentine's Day on Monday, so this weekend the hotel will be full, even if they don't do any marketing really. But
Right.
10 days ago on Wednesday in the middle of early February, the hotel is probably pretty empty, and it's
Yes.
difficult to. The hotel has a lot of fixed costs in terms of cleaners and
Yep.
things like that. Like their variable costs are a lot lower. So from the hotel's perspective, it's a lot better for them if they can fill that room on Wednesday last week than if they can sell out the Valentine's Day weekend slightly quicker. And if you're not careful with your marketing, particularly in PPC, all that will happen is you'll sell out. You'll sell out on Valentine's Day in like early November rather than in late November, and your Wednesdays in January will still be empty. So
Right.
yeah, so you can do things around looking at room availability to change your bidding and stuff like that, which is that's very data intensive and relies on connecting to their back ends, the hotel
Right.
room or the hotel
And
chain
so
back
what would you
ends.
say was the next step in your maturity towards using, it sounds like at that point, maybe some inventory and maybe some scripts that would, go back into the platform to instruct it, well, go up or go down. But, what was next for you? What
In
did the
terms of
progression look like?
that was already like that's still a pretty complicated project. Um, so
Yep.
the project I was first talking about in terms of weighting bids depending on hotel room availability, like that's basically just me responding to what I expect the conversion rate to be. Um,
Yep.
yeah, no one's going to book into a full hotel basically, or if certain room types are not available, then the conversion rate is lower. Often you can't tell from the search term whether if someone wants a deluxe room and they're all sold out, they're going to click, but the conversion rate is lower. So that it's more
Yep.
responsive at that level. More recently, it's been questions around like, well, how do we value this click in the first place? Like, what's the difference to the business if we are at 10% occupancy on a random Wednesday in January versus 50% occupancy? Like how much does that make us versus versus the alternative?
Right, because that's
Which is
the lever, right?
well,
Independent variable, dependent
different
variables.
people have different levers. So when I'm earlier in my
Yep.
career and I'm just managing paid search and I'm like, I want to make that number go up without making that number too big, then that like I've got different levers to pull and I'm using I don't really care. I'm not worried about like the fixed cost versus variable costs for the hotel. I'm worried about what's the conversion rate when someone goes through to that landing page.
Yes. And
It
as you
doesn't
said, it
bother.
varies over time.
Yeah, it doesn't bother me that the hotel's at 80% occupancy, so they make a lot more money on every that's their fixed costs covered, so they make tons more money or whatever the figures might be. Whereas more recently, it's kind of like how much more would it be worth to the hotel to have someone stay when the hotel is practically empty, so that at least they have some cash flowing through, and there are certain cleaners. It gets more complicated than that because a lot of cleaners are on. Do you have 0 hours contracts in Canada?
Don't know.
That's in the UK. That's what we call it when they don't. The cleaners don't have guaranteed hours, so they can. Some weeks they might not be brought into work, like when the hotel's
Yes.
empty.
But the point is taken that this data model is getting rather large.
It's getting more and more complicated.
Wherever possible, you want to try and get ahead of it.
There's thresholds where, like, below a certain amount, at certain occupancy percentages, it jumps up and, like, okay, well, now we can bring in another cleaner, and that changes the model,
right,
sort of in between those points. So you have sort of discontinuities in how
Yep.
worthwhile it is for. If you're at the point where you book one extra room, and then suddenly, like, okay, well, our current cleaning staff won't be able to clean all the rooms. We'll have to bring in an extra person just for this one room. Then that one room is less profitable than the previous room you just sold.
Right. So are there, if gauging that level of PPC, levering for a hotel business is more than just circling the holidays on the calendar, what tools do you start to employ to be able to handle a more nuanced model?
Well,
how did you tackle it?
For me, the hardest part is getting that information out of the hotel, because
Yep.
I'm not normally dealing with, like, an operations manager. I'm dealing with someone whose focus is marketing. So we're kind of if I talk to them, we can kind of be aware of all these barriers, and we're like, oh yeah, that sounds like the sort of thing that might be an issue, or that might exist, but it's not the sort of thing where either of us are like, okay, well, yeah, well, this is these rooms are really profitable, these rooms are marginal, these rooms aren't worth it unless we're already really busy.
Yep.
So it's like getting that information first of all, to understand, like, to just to be able to build the model of, like, this is at this level of occupancy, an extra room is worth this. At this level of occupancy, an extra room is worth this. Like, I find that, like, the hardest part, because you've also got to remember that I'm talking about this now when I already understand the business. But before I start to have these conversations, like, I've never run a hotel. Like, I don't even know what these things are for a lot of businesses. So being able to extract that information and to understand what to understand what the levers are available is the hard part, I think. And then once you've got all that
there
down,
has to be, yeah. The human has to understand it, but I want to bring Brett in because, Brett, in past conversations, you've made rather clear to me that as long as the information can be put in, and we're talking, in the last couple of years, that there are tools that use machine learning, and the beauty is that it will recognize patterns, and it doesn't necessarily have to understand the underlying mechanics. What tools, as Richard has been talking, come to mind for you as how you would parse and how you would start to analyze this data?
Well, I mean, it's interesting. I was going to actually ask Richard a question based on his conversation. I didn't want to interrupt you.
Go for it.
How much, for example, I mean, we talk about, like, unsupervised learning, supervised learning, and all these different concepts, but at the end of the day, like, probability to me is the most powerful concept when it comes to this stuff. How much does probability probably the most powerful tool that you use?
Yes, so certainly on a marketing side of things, I agree. It's all about, so if you take it back to paid search, it's all about the conversion rate, which is, that's, I don't want to dive into the maths before we're ready, but that's like a noisy
Yeah.
Go
observation.
for it.
The conversion rate you observe is not necessarily the true conversion rate. But obviously it's the true conversion rate that you want to base your decisions off. So you get 100 clicks and your true conversion rate is 1%. You might get 2 or you might even get 3 conversions off your 100 clicks under that
Yep.
true conversion rate of 1%. So then your observed estimate is 3%, which is significantly higher than
Yep.
the true value, which can lead you to make all kinds of weird decisions or bad decisions. But to take
And Richard,
talking about paid search a lot here, you end up you can get it. You can get a better estimate if you have more data. Obviously, if you've got like 1,000 clicks, then that's going to give you a more accurate estimate of your true conversion rate than if you've got 100. And if you've got 10,000, that'll give you a better estimate again. But the way you get more data is either by looking across a longer window of time, which again, we know that these things aren't constant over time, and including data from like 3 years ago is probably not telling you very much about what the value is right now. Or if you're not looking across a longer window of time, you're grouping more and more keywords together or more campaigns together, and instead of saying like what's our estimate for this campaign, you're like, okay, well, what's our estimate for the whole account? You can estimate very accurately what it is for the whole account because you have a lot of data there. But that's a much less useful estimate because there's a lot less you can do with it. So you're in this constant tension.
Richard, as we get more granular, are you recommending that marketers have to get comfortable with upper and lower bounds and the concepts that statisticians use to try and describe the probability where it isn't just a single number?
I think those concepts are important at all levels, but they make more difference at the more granular you look. It's a constant tension between I need to segment this as much as I can to get the best insight. Okay, I've got this keyword in this location, and I'm only going to look at it on Monday between these hours. That's highly actionable insight, and if you can spot like your conversion rates are higher or lower there, then you can do a lot better than everyone else in the auction with that. But
I think
the more you
changed also. I was about to say, I think that's what's changed. Like, I mean, the word statistician is an interesting terminology, and I don't know if you would agree, Richard, but like when we talk about statisticians, I see them as one dimensional almost, right? But when you talk about when you factor in data engineering, data scientists, and stuff like that, all of a sudden it becomes like almost like a 3D puzzle, and I find everything now is linked. So when something happens in A, say if you have A, B, and C out there, everything is interlinked, and I think that's the concept that people have to get familiar with, or this is how they can become more successful if they can link events somehow. So if something happens here, and then say you have another scenario over there, something happens in A, what is the effect to A, B, and C, or all the way down the line? Because they're all interlinked. Lately, that's what I've been stumbling. I don't know if you can expand on that more.
Yeah, no, that fits in really well actually with an idea that I guess I could have been working towards. So, how I solved this when I was doing PPC is with what is called a hierarchical model, where you want estimates at a very granular level. So, say the keyword level. Or that could be the keyword day level or the keyword creative level or something like that, like something really granular. And by the nature of it, that data is going to be very sparse or limited. Because if it wasn't, why are you even talking to a statistician? Or like, why don't you make it more granular because you'll do better? so you've got a limitation there that's like that, and that limitation is kind of built into how people had to do paid search at that time. But people set up their accounts with a hierarchy where they have the bottom level of keywords, or like their ad group, and then everything. You can assume that in a well set up account, everything in that ad group is similar. And then the ad groups are grouped into campaigns, and you can assume that the ad groups within the same campaign, they're more similar to each other than some other random ad group in the account. And then you can do, there's other ways people will group their campaigns together as well. Like they might have a campaign for each location, but then all those campaigns across the locations, you'd expect those campaigns to be similar to each other in some way. And the hierarchical model allows you to kind of pool data across these different levels, so that your estimate for a keyword, like it uses the data you have for that keyword, but there's not very much of that. So it takes some of the data from the ad group level to give you a more precise estimate, with the idea that this keyword is similar to the other keywords in the ad group, which is like what Brett was saying, where something that you observe over here can actually have an effect on what your estimate is for something over here, depending on how you've set the model up and how much the model's learned about whether those two things are similar.
Right. And if they get it wrong, then they're really messing up the accuracy of their analysis. They do need to understand, or at least be working alongside a marketer who can describe where similar data resides.
That whole model that I was talking about relies on similar things, the things in the groups. You can define the groups in lots of different ways, but the things within the groups need to be similar. And this model, I'm sure you could machine learn those things, but the way I'm talking about it, machine learning isn't figuring out what things are similar. It isn't figuring out what those buckets are.
No.
The marketer has decided that and said, like, okay, well, all these keywords are similar, or they're going to perform similarly. And then what the model is doing is saying, like, what is the degree of similarity between the things in the bucket, essentially.
Right. So a question for either one of you is, when you are looking at similar data and you are trying to use some of the new tools to boil it down, either classifying it, but probably more doing some regression on it and understanding how the independent variable affects the dependence, which tools do you like to go grab that are accessible now for doing this sort of thing? Ones like, there's notebooks out there. There's we have different plotting tools, and you can use Python or R to bring that data through several different forms of analyses. Whoever of you'd like to weigh in on that, I'd love to hear it.
Well, I guess Jupyter Notebooks is a great. Oh, sorry. Go ahead.
I was going to say, start at the very.
I was just about to say that.
Go on, Brett.
Oh, I was about to say that Jupyter Notebooks is always a go-to. Lately, I have a subscription into like Colab on Google. I run like Jupyter Notebooks locally on my computer, but Colab to me is a very useful tool. You can connect it into different sources too, and it just becomes a rapid way of modeling data. So when you're ready to put it into production, it's just it works, and it's just a great tool for rapid prototyping. I don't know if you'd feel the same, Richard, on that, but to me, it's that's what we have to do.
And certainly, what you're saying about like getting stuff into production, that's almost like a whole different game, and yes, it could.
Yeah.
Notebooks would be a starting, or you need to start with code for that kind of thing, I think. But if we're just talking about regression, then I think you can go a long way with a spreadsheet, as long as you understand what regression is and what it's doing, You can do scattered charts
Okay,
to
so
analyze your
Richard, take
variables.
us there. Sure. So if someone has only a spreadsheet, and let's say they have not brought stuff into a database, start us right at the kindergarten level. What can they use on a spreadsheet to identify, let's say, a straight linear regression?
So a good rule is that no machine learning is allowed until you've plotted the data. So plot the data.
I love it. And like a scatter plot?
Yep, scatter plot is good. Histograms is very good as well. A histogram can really reveal to you if there's outliers, or I don't want to call them outliers straight away, but extreme values in the data, and then you can decide if they are outliers or not from there. So sometimes an extreme value is very important because of its extremeness, and sometimes you might think, oh no, we were doing something weird then, I don't want to count that in my analysis, because that won't happen again, or oh, the temperature was really high for that one because the room was on fire, or whatever it was. So you could, and that can help you establish like basic relationships between your data. If you're wanting to do a linear regression and you do a scatter chart of your dependent and independent variables and it looks like pure white noise, then that's a pretty bad sign, right? And you don't need a fancy algorithm to tell you that that's a bad sign. And the same way, if you do that plot and it's pretty much a dead straight line, that's a very strong sign. And you can do all the tests and statistics on it, but again, you probably, in that case, you don't need fancy statistics to tell you that there's some kind of relationship there.
Right. If I do more of this, then that happens.
Yeah. And then you can build your model. I can't remember what the name of the function is, because I probably wouldn't use a spreadsheet for this because I'd be a bit quicker in R. But you can build your linear regression model. You can plot your residuals on your training set. The residuals is like the difference between the model prediction and the actual value. So again, you can estimate how good your model is by looking at the size of those residuals. You can plot your residuals to check that they are distributed in the right way.
So let's talk about. Just want to return to one little thing you said there, because I think a non-data person would really appreciate you unpacking test your model. So maybe just take us through that, and we could talk about that maybe with a forecast. How is testing your model even done?
Okay, so it's a bit different for forecasting type models compared to others, because that's there you're working with time series data where you don't know. The data is not independent in the same way as it is for other linear models. So the whole idea of like a forecast is that the results I'm going to see tomorrow depend a bit on the results that I'm going to see today. Whereas if, say, you're trying to establish, is there a relationship between people's height and their weight? Like your height and weight.
So let's take that one.
Your height and weight is independent of my height and weight, which is independent of Brett's height and weight. Whatever my values are, that doesn't change what your values are. But if that's not the case when we're talking about forecasts, where what you observe earlier in your data is kind of expected to affect what happens later in your data, and that's the whole point that allows us to forecast. So if we take our heights and
so go ahead.
So if we take our heights and weights model, the idea here is that we will you could do it either way around, but we'll say we're trying to build a model where if you input someone's height, it will tell you what their weight is. And we want that to work for people who we haven't seen yet. So we collect all our heights and weights data, and then what we do is we separate out a certain proportion of that, 20% maybe is a rule of thumb there, but there's certainly arguments for
Right.
less than that if you have a large data set. And then
So we don't feed it everything.
You don't feed it everything. You'd hold back 20% of the data, say. Then you train your model on the remaining 80%, which will say something like, okay, the weight is, I don't know, 2 times the height. What units are we even using here?
Whatever.
The weight is whatever times the height plus a constant, because we're doing linear regression, right? And those parameters, the slope of the line and the constant, the intercept, they're fitted from the data that you've given it, which is what the machine learning is. So then you have the question of, okay, well, how good is this model? Like, how well will it predict someone's weight given the height? And you don't want to give it the data that you've trained the model on, because it's already seen that. Certainly, that's like maybe that's less of a worry with linear regression, but certainly if you're going to use a complicated neural network or something like that, then you could end up with the neural network perfectly learning the heights and weights of everyone in your training data set, but that doesn't tell you anything about anyone who's not anyone who you haven't seen before. So instead, you take the 20% that you've held back, the test data set, it's called, and you run the model on that. And then you can see what the difference between the model prediction and the actual values are, and that will give you an estimate for how good the model is.
And depending on how satisfied you or the client is with that, you're either going back to the drawing board or you're saying, nope, the model's good enough to use.
So there you're getting into another problem, which is around model selection. So what I've just described to you there, you have your test and your train set, and the idea is that you don't want to evaluate the model on the training set, because the model's seen that already, and you'll end up with a model that performs better on the training set than you would expect in real life. But if you're going around this cycle of like, okay, well, let's see if the model's good enough on the test data, and if it is, we'll keep it, and if it isn't, then we'll go back to the drawing board. Is that whole process is a learning process, which is including your test set as part of the learning process. So you're more like, if you go through that enough times, you're going to end up picking the model that performs unusually well on the test set, and that problem won't generalize again into unseen data. You know, if you imagine that if in like some weird world your model performance is essentially random, then you do that enough times, you're going to pick the one that's randomly best on the test set.
Oh no.
Without that performance generalizing to unseen data. This is less of a problem than conflating your test and train set earlier on, but in that situation, if you're going to go around that loop a lot of times, then you might do something that's called cross-validation, or you might keep a third data set out, called the validation set. It's certainly, if you're doing some machine learning consulting and your client is savvy, then they will hold that validation set back from you and not even show it to you, so you can't cheat.
Also, yeah, I mean, on that note, you know, the whole idea of false negatives and false positives, how well is your data fitted, right? I know some of these concepts might be a little bit heady, but essentially, like, sometimes you can run your model and it could look like 80%, but it might be actually less when you factor in false negatives and false positives. Essentially, I don't know if that's a good way of explaining it, Richard.
I think
like
so.
Just simplifying. I know it's not.
And the idea of false positives and false negatives, and regression errors. Sometimes you overestimate, sometimes you underestimate. When you're talking about a business, the consequence of those different errors can be very, very different. If you're using a regression model to decide how much stock to buy, and you underestimate, then you sell out, and that's bad. You miss out on revenue that you could have got if you'd had more stock. But if you overestimate, then you've spent more money on all the stock that won't sell. It's taken up space in your warehouse. You need to ship it as a discount. You need to sell it at a discount later on in the season. Those things. The overestimate and the underestimate don't have equal consequence for the business, and it's the same with false positives and false negatives. So sometimes if you say like, okay, well, this is category A when actually it's not, that's not a big deal. And sometimes you might say that if you're doing things like it's not so much a marketing thing, but if you're doing like survival analysis or machine maintenance sort of things, and that you predict like, oh, this machine's about to break, and then they send a technician out at great cost to run some more diagnostics, and it turns out the machine's fine. They're not. So it can be very complicated to weight those things, and it kind of goes back to what I was saying earlier on in the business, earlier on in the podcast, with the web analytics setup, is trying to get that information out of the business about what the consequence of those errors are, is really difficult.
Brett, I know you've had some fun with some tools that allow you to look at what might be the best way to find the relationship in a data set. You've talked to me in the past about Pomegranate. You've talked about some other ones. Could you maybe just take us through what some of the capabilities are once we're using a database and some of the machine learning tools out there?
I guess we all have our biases when it comes to tools, first of all. And I come from a different background, a little bit of a different background from Richard. However, we're essentially doing the same thing. We're analyzing the data. At the end of the day, you want to get as accurate data as possible, right? And to do so, you're only as good as, first of all, you're only as good as your data. And I think your marketing team is only as good as your data science is. Like, it's kind of funny. Like, before I get into that, I think it's important. Like, there's been a huge transformation within PR and marketing. In the past, I guess we'd all look at a show like Mad Men. I know it's more around the advertising, but that's the sexy part, right? And everybody just thinks that marketing is about coming up with great ideas. I think it's becoming more about data, especially as we're getting more and more data these days. I don't know, Richard, I guess you're seeing the same thing. That's why you're employed. That's why, people are looking for guys like you that especially know the space very well. And it's, getting back to what Richard said about, first of all, spreadsheets. That's how I got introduced to Glenn, by the way. I remember at the organization that I started, the marketing was a mess. And part of the reason why the marketing was a mess, nobody was collecting data. So we started out, I insisted that we set up spreadsheets. We start analyzing and looking at the data. And essentially what came out of it was, oh, we're doing well here. We're doing well here. Oh, wait a minute. And ironically, we weren't running the advertising at the time. Somebody else within the organization was running the advertising. It came up, and I'm not an area expert in advertising. So what did I do when I saw that those numbers were bad? I reached out to somebody like Glenn. Actually, I reached out to Glenn, and I tried to bring him in at the time. But, it comes down to that. Like, it's just basic numbers at the end of the day. And again, getting back to, everybody looks at marketing being sexy, right? It's almost like nobody really wanted to deal with the truth, which was the math. That was the important thing. And this is why guys like Glenn, guys like Richard are so important. And, you can't be a successful organization, first of all, without having guys like you guys, first of all. So I just wanted to put that up front. Now, some of the tools that I got into, that opened my eyes. And again, these are my biases. I really like unsupervised learning for identifying clusters. I don't know, Richard, how much you guys are doing that, but sometimes if you want to take a deep dive and you really don't know what's going on in the data, sometimes, clustering with using unsupervised learning, like essentially to explain to everybody what it is, it's a simple concept. You essentially run the data you have, and you have to clean the data. You have to make sure it's good, first of all. But when you put it out there, it might uncover things that you never ever heard of before or never seen, like, or certain categories of data, or just on certain behavioral things. So, uh, and then the next thing I got into, I took an AI course, and ironically, we were learning, it's the same thing, like, when you look at automated cars, right? Out there, like, everybody knows Tesla and the self-driving cars. So what they're using is reinforcement learning. But you can't just turn on a car and roll it out on the street and think it's going to drive. Like, the way something like reinforcement learning works is essentially the car is going to drive around. If you just let it loose, it's going to run into people. It's going to go through stop signs. It doesn't know what's going on. And Richard and I were talking about probability about this prior to the conversation. To me, it's an undervalued, like, probability. To me to me it seems like it's underused within people, because it's not sexy. So people kind of dismiss it sometimes. And where it becomes really powerful, and you mentioned pomegranate, is where you have probability and you're able to connect different probabilities throughout the problem you're trying to solve. And essentially how it works, when something happens, say in A, if you're using a tool like pomegranate, essentially it's almost automated. And if you have your probabilities right to start off with, or your assumptions, I should say, I think that's I know, Richard, you're more on the math side than I am. You need to have assumptions, first of all, when you start off from scratch, right? And it does have to be based on data, but you still have to start out. You have to kind of place a marker out there. I really like a tool like pomegranate because it kind of just automates things. It makes it a little bit more clear. And then as things change, hopefully what you're seeing, and if you've built a good model, when it changes here, you can see the effect of it throughout your entire ecosystem. I don't know if that's a great way of describing it. I'm going with it.
Yes, I'm not,
but I don't know, Richard.
I'm not totally familiar with pomegranate, but it sounds similar to other tools that I've used, and the process that you're describing there is very similar to what the hierarchical model for estimating conversion rates is that I was talking about before, where you learn a little bit about keyword. You get some very specific data, like get a new conversion on keyword A after 5 clicks or whatever, and that updates your estimate for what the conversion rate of keyword A is, but it also updates your estimate for everything else in that ad group, and then that filters up to the campaign level and then down to the other ad groups and keywords.
And how I got introduced, like, and again, it's just another tool at the end of the day, right? And it's just taking something and making life easier. And I think that's what these tools represent. And how I got introduced to this particular tool was kind of interesting. So we took this reinforcement learning course, and we essentially had to build a neural network that basically learned as it went. And the irony of that is, when we had to use probability for the same problem. Now, neural networks take a lot of computing power to figure things out, and it really takes a lot to get it working. But when I rolled in probability into this certain use case, the probability hardly used any computing power whatsoever, and it was able to solve, maybe I built a bad network, fair enough, but it was able to solve the problem way better than the reinforcement agent that I had created. And so actually, when you look at it, and I was talking about the situation with the car, ironically, a lot of these learning models, right? And these learning agents are pre-populated, like they're usually combined. They're usually populated, first of all, with probability. So you're not going to turn on a car, for example, and let it bump into people, let it go through stop signs.
Right.
It's going to have a starting point. And I guess the whole point is there's all these tools out there and they need to be applied properly. And one of the concepts, and it was interesting, we were talking about false negatives and false positives. There are ways of also solving those problems. And one of the concepts, and people should just do their own research on this, but leveraging something like ensemble learning, and it's a really simple concept. It's essentially, you might create a model that's 80% effective. I think that's a good start. Now, if you can combine that with another model on top of that, that's going to help identify and solve those other problems, right? You can get the best of both worlds. So say if Richard creates his model and he gets to 80%, that's great, right? But it'd even be better if you could somehow identify some of the issues within that model and try to solve it with another model. How about that information?
So in my spreadsheet, linear regression example from earlier, maybe you look at the residuals and you're like, okay, so this model's pretty good everywhere except for these particular instances where it makes a really bad prediction. And then some of what Brett's talking about is like it would automatically figure out what was those instances had in common, but maybe you as an expert or you as someone who knows what's going on can be like, okay, well, these are people who have a different relationship between their height and weight for whatever reason. So maybe we need to train a different model for those people, and then you can combine the two predictions to get a better estimate at the end.
Mm-hmm. Yeah, and it's getting better and it's getting faster, and this information is now at the level where we should maybe look at pushing it back into the ad platform. The phrase that is making the rounds these days is automation layering. So we're aware that there is AI, there are algorithms clearly inside of these ad platforms that are optimizing for something, but we want to try and take these results that we've gotten and layer them into the results, which is a kind of ensemble learning, if I think of it that way. Richard, what would you say are some of the good use cases for how you do that?
I'm just thinking about it's a problem that I'm having at the moment is that like there is a lot of AI or a lot of machine learning happening in these platforms already. So one of the kind of projects that I work on quite a lot is around trying to estimate what your paid search budget should be or what it could be. Like what's the optimal spend?
Right.
And if you
depending on when you spend it.
Yeah, exactly. So one output from that might be like, oh, I think you should be spending more on a Monday and less on a Wednesday. But the data the data that's used to train the models that I'm using to draw those conclusions comes out of the engines where there's already been some kind of machine learning or some kind of AI controlling how much spend is happening on each day. So what my model sees is like, oh, you get a bit less on a Wednesday when you spend a bit less, but those things are not necessarily causative in the way that the model expects because the engine's AI has already influenced the spend for that particular day.
Yes.
I'm not quite sure what the answer to that is, other than do an experiment. But obviously that's almost a different.
Yeah, we're in these are challenging times because we don't have the ability to opt out. But Richard, when it comes to forecasting and let's say taking that number of conversions or the value of the conversions that we might want to try and forecast, you've built something that tries to help there, right?
Yes. So I have a product called Forecast Forge, which brings some forecasting algorithms into Google Sheets, and one of the uses for that is, as Glenn says, forecasting paid search returns based on your historical data.
And I view it as kind of a truth serum, right? That you might put up, you may not immediately feed it back into the algorithm, because the algorithm is maybe going to get confused, but it's at least going to help you see another set of what could be happening over time, so that you have an expectation. And when the ad platform's algorithm seems to be going in a totally different direction, you may be able to, in a supervisory way, step in and alter course.
Yeah, definitely. And I think that applies across many different domains. If you're comparing what's happened recently against a forecast, that gives you a lot more insight, or a lot more of a trigger for I need to do something, than if you're comparing against a week over week or a year over year number. Because as we all know, there's particular times of year, or more recently with COVID lockdowns or whatever, where week over week, month over month, and year over year numbers, everyone knows they're not meaningful to start with, so they would tend to ignore. They're like, oh, we're way up based on our month over month comparison compared to what we expected, and everyone's like, yeah, great, beers on me.
And in early 2022, going backwards 1 year with data may not be the best way of trying to figure out normative data going forward.
Yeah, exactly. And I'm not saying that problem doesn't exist at all if you're comparing with the forecast, but it is a lot less of a problem, and it won't bite you quite as frequently.
Yeah, I think a data scientist is not a robot, right? At the end of the day, they're very creative individuals. They love the data. They love solving for the information. Nothing is static. There's always considerations you have to consider, such as seasonality is a huge one, as Richard just alluded to, and then you have like black swans, right? That sometimes you just have to throw out the complete model, such as whether it's 9/11, the pandemic. It's
things like the pandemic are really tough from a machine learning point of view, because the last global pandemic was in 1918 or 1919, and no one has web analytics data going back that far, and very few businesses have any kind of business data going back that far. So yes, from a sort of what can we learn from the data on this is a very hard question, and I think that links in with the ideas that Brett's been saying about sort of specifying your probabilities and things almost separate to the model, and then the model builds on top of that.
Yes. So the last question I have for each of you is more one of how we can move along and progress in our own data science maturity. Let's imagine that the average listener here doesn't, work in a place where they can afford a data scientist. So, Richard, I imagine that, one of the answers you would have is, what can they do is look at tools. Go into your Google Sheets marketplace for add-ons. Go into some of the other ecosystems, Data Studio connectors, and places like that have models that people have built, and see if they might be right for you to apply. But I'm interested in hearing as well from Brett, what do you both encourage people to do to get their feet wet here?
Well, I think Richard brought it up succinctly before. Just utilizing spreadsheets is probably a good start. Start collecting your data, start measuring everything, start measuring like simple things such as like your interactions, even on social media. If you're engaged in social media, essentially I've been taught, I have taken a PR program in the past. And I remember they said that if you're not analyzing your data, your campaign is a failure. Doesn't matter how good you think it is, it's a failure unless you analyze it. And I think that's, and that's what motivated me to develop the application I did in the PR space. Nobody was measuring anything as far as I was concerned. And that's what motivated me to develop one of the first SaaS media monitoring and analysis solutions. and I was kind of blown away. I think marketing, in all fairness, was slightly ahead of the PR crowd, so that gave me like some fresh ground. But that said, I still think that my experience with the marketing people today, uh, they're getting better, right? But there's still a lot of work that needs to be done, and they need to have almost like a data first strategy in my mind
Yeah.
before they even start talking about creativity. One of the things too, like one of the things that got me started was, and I don't know, I know it's kind of looks reversed to me here,
No,
but
it's
this is called
right way
predictive
round for me.
analytics. What's that?
It's the right way round for me.
Oh, okay. So I got Glenn to read this book. I read the book. I got started on it. Even the concept of ensemble learning before I even got into any of this. I mean, that's where I learned what ensemble learning was. There was an excellent use case in this. They were talking. I don't know if you remember, Glenn. They were talking about the cell companies, right? And the cell companies wanted to predict whether somebody was going to leave their company and whether they should reach out to them.
Yes.
Right? And back then, they were dealing with issues such as they don't have the same issues as we do have today. Like today, we can outreach to people through email, text messaging, and stuff like that. Back then, they had to like reach out to people through mailouts.
Yeah.
And they could be very expensive.
Yep.
So what they had to do was predict who was going to leave, and then they would send a mail out, try to entice those people back. But then we talked about ensemble learning, and this is where you have to get more sophisticated, and they did. They would send out these mail outs, and sometimes they would inadvertently alert people, maybe it is time to leave.
Yes.
Right? And this is where we have the false negatives and false positives, and
Right.
where the ensemble learning comes in.
It's the opposite effect of what they wanted.
They had to put a model on a model to try to also isolate those people.
Yeah, so they could suppress them. Yep.
I could inadvertently warn them, or I could give them basically the go-ahead to change companies.
Yep.
Right? So everybody's becoming more and more sophisticated, but I do recommend people, like if you're just a marketer, I'm not going to say it's an easy read, but I'm not going to say it's also, I think it's a great starting point.
Yeah.
If you're a marketer, you need to get familiar with the math. You might have got into marketing because you hated math. Guess what? Guess what? The joke's on you.
Yeah.
You have to at least bring yourself up to speed to at least to be able to talk somewhat intelligently to somebody like Richard or Glenn. Like Glenn, I think you're the perfect in-between guy where you're able to translate a lot of this stuff. Could be because you have that basic understanding. But guys like Richard, I'm telling you right now, they're the most important guys in your organization as far as I'm concerned.
Yeah. And I'll just wrap here. We're kind of sidestepping, except Richard did allude to it earlier, where it's ironic. A person who does what we consider to be hard, which is the analytics, is saying that one of his hardest things to do is to pull the data out of different data sources, and we kind of have to leave that off to the side. But let's imagine that this information can be sitting or pulled from different data sources, as long as it's in a place and a spreadsheet with, let's say, a VLOOKUP table that takes two things where there's a common identifier between them and can marry them together. That's enough of a starting place where you can then start to play around with the charts, possibly bring in an add-on and do some of the basics that will allow you to convince people in your organization that they need to delve deeper into this. Would you agree, Richard?
Yeah, definitely. I think there's a whole, to be a data scientist, there's almost two orthogonal parts to it. There's the can you think through problems in a data sciencey kind of way, and then there's the can you code solutions to these problems. And I think there's a lot of people who can think through things in a data sciencey way, but who don't have the coding skills. Like they're not comfortable in code, or they're okay with like running a notebook that someone else has made, but they're not really very sure about, making deep changes to it. Like there's all sorts of levels where that can happen, but being able to think through the problems
that's beautifully expressed. Yeah, when it's all contained in one person, you can, but let's not diminish that the marketer, even if they don't have any of those coding skills, they can dictate requirements. And if there's another person that has the coding skills but no business knowledge and way of coming up with the questions, that they can run a notebook. And between the two of them, you can get there.
That's exactly my pitch for Forecast Forge, is that what I've found with forecasting forecasting projects, and I've sort of mentioned this already, is that often it's the domain-specific knowledge of knowing what's important for the business is more important for making a better forecast than being able to use the fanciest transfer learning algorithms or something like that. So it's the combination of what I want Forecast Forge to be able to do is allow people who can think a bit like a data scientist and try and think like, okay, well, maybe if I added this information in, the algorithm would make a better prediction. But they're not comfortable with doing that in code themselves. But the Forecast Forge thing is that they don't need to be able to do it in code. They can do that in the spreadsheet that there's tens of thousands or millions of people who are very, very good with spreadsheets and know a lot about their businesses that they work with or that they work in, but who don't know how to adjust a forecasting model in code.
Yeah.
And conversely, and these are the data scientists you stay away from. If they're not invested in your business, or they don't care about what they're trying to solve, I don't care how clean their code looks, how good a programmer they are, how good of a data scientist they are. If they're not invested in the problem, you got a problem, because basically everybody has to be invested in the problem that they're solving. And this is just common sense, but it happens more than we'd like to think. And
you can become enamored with the tools and start to think that is your real gig, not trying to figure out how to use the tool to solve a business problem.
And to put this in perspective, I've seen people that, they might not have been the best coders, but they were effective because they understood the problem they were solving. And I would hire one of those guys over like the best programmer in the world if he didn't really give a damn about what he was solving.
And that's kind of so I've been one of those guys who you don't like. Like I've started a forecasting project and I'll be like, oh yeah, I'm going to try this that I read about. Can't wait to get stuck in on this algorithm, and I do all the fancy machine learning stuff. My error rates are getting better and better with each iteration. I'm super pleased. It's going really well. I make the forecast. I'm presenting it back, and they're like, "Oh yeah, that's great, Richard. Thank you." But it's wrong, and I'm like, "Well, what do you mean it's wrong? This got a really low error rate. How dare you say that it's wrong?" And they're like, "Oh, but we're launching a new product range in July, and we're going to be doing a load of TV around that time, and your forecast doesn't show that at all." And it's like, oh, well, duh, of course. Like, if I'd cared enough to ask what their marketing calendar was, then I wouldn't have made that mistake, and the forecast would be a lot better. So it's that kind of thing where I'm like, it's getting that knowledge into the system so that the machine can learn from it that is going to give you the best results. And as Brett says, it's kind of like you need someone who cares to make that happen well.
That's right. Yeah, underneath all of this, you gotta care. I am so glad that the two of you joined, and I think we've really helped the listener to get a grasp of this. Perhaps not, they won't be able to just run and execute with all of these things right away, but it'll give them a sense of where they need to perk up their ears and lean into conversations, or to try a couple of small experiments so that they can get a sense for what this does. So listen, thanks to you both for coming. And to the listener, if you found value out of this, I hope you share it with someone, or put something that you heard today into a Google search and that you get going on finding out more about this. And I hope that you found something that you can make your funnel even better with.
Thanks for listening. Follow the show on Twitter @Funnel Reboot. If you like what you have heard today, please consider leaving a review wherever you get your podcasts.